Alright, now for tutorial question 10a, okay, again now you have a real life problem, okay, and a table given to you with all the pieces of information. Okay, so during the NJC College Day Fun Fair, Justin set up a fruit store to make 3 types of fruit juices: apple, mango freeze, and banana milkshake. Okay, so it is told to you that the production of each fruit juice requires cutting, blending, and packaging. Okay, and the table actually highlights to you the time required for each of the processes. Okay, so they told you that 35 cups of juices were made in total. So the first step you should now do is you define your variables. Okay, so perhaps let us use our usual x, y, and z. Okay, to be the time required or rather to be the number of cups of apple juice, mango freeze, and banana milkshake. Okay, made respectively. Okay, so since 35 cups were made in total, okay, so the first condition, total number of cups made, okay, is 35. This will give us our first equation: x plus y plus z equals to 35. Okay, and they told you that the total amount of time spent for all the processes, for all the fruit juices, is 204. Okay, so total time spent will give us our second equation. Okay, so this would be for apple juice. Okay, if you look at the column corresponding to apple juice, the total amount of time for all 3 processes added up together, which will be 6 minutes. 1 plus 3 plus 2. Okay, so 6x. Okay, so similarly for mango freeze, plus 6y is also 6 minutes, and for last one will be 5 minutes, 5z. Okay, it totals to 204. Okay, so we have now equations 1 and 2. So we require one more. Okay, and they told you that the total amount of time spent on the cutting process was 50 minutes. Okay, so just for the cutting alone, okay, we will need to look at the row corresponding to the cutting process. So 1x, which is x, okay, 1 minute was spent on apple juice for each cup. Okay, plus 2y plus 2z, okay, is equals to 50. So this is equation 3. Okay, so let us use our most favorite graphing calculator again. Okay, go back to the main menu, select simultaneous equation solver, 3 equations, 3 unknowns, and your entries in the array of numbers. Okay, so 1, 1, 1, 35, okay, followed by 6, 6, 5, 204, and finally 1, 2, 2, 50. Okay, enter and press solve. Okay, you get x to be 20, y to be 9, z to be 6. Okay, so again at this step, please check back to the question to see what is required from you. Alright. Okay, so actually I have kind of skip forward, okay, to solving already. Okay, so do read the question carefully. Part 1, write down the 3 distinct equations involving unknowns. Will be equations 1, 2, and 3. So this would be for part 1. Okay, and write down find the values of x, y, and z. Okay, this will be part 2. Okay, sorry. Okay, so I forgot to mention one thing. Okay, when you are solving the system of linear equations, it is important that you write down the what you have used. Okay, so using the GC in poly simul 2. Okay, do write this, is quite rather important. Okay, to show how to indicate your working clearly on how you have obtained the solution. Alright, so this is for 10 part A. Okay, now for 10 part B. Okay, now they have given to you this information. Okay, so they told you the inverse of this matrix. Okay, 8, negative 6, 3, 7, negative 5, 1, negative 1, and the last row 1, negative 4, 2. Okay, the inverse of this matrix multiplied by the column vector 43, 35, and negative 6. Okay, will actually give you the column vector 8, 4, 1. Okay, and they tell you that there is they ask you to explain why there is no value of x that satisfies the following set of equations. Okay, 8x cubed minus 6x squared plus 3x 7x cubed. Okay, sorry, 8x cubed minus 6x squared plus 3x equals 43. 7x cubed minus 5x squared minus x equals to 35. And lastly, x cubed minus 4x squared plus 2x equals to negative 6. Okay, so what I can do is I can rewrite this set of system of linear equations, okay, into a matrix form as follows. Okay, so since I have the coefficients 8, negative 6, and 3, okay, on each of my variables x cubed, x squared, and x, I can write in this manner. Okay, and the other two equations accordingly as well. Okay, so this system of linear equations, okay, can be rewritten as this matrix equation as shown. Alright, now what I can do from here is I will now take inverse on both sides. Okay, so if I will take inverse on both sides, okay, inverse of this matrix here, the one that is being boxed up in red. Okay, the matrix of this the inverse of this matrix, I'm going to multiply it on both sides of the equation. Okay, so what I'll get is, since the inverse of the matrix multiplied by itself is the identity matrix, okay, in other words, it will not, okay, it will become the identity matrix as follows. Okay, but the identity matrix multiplied by any vector is itself. Okay, any vector is the vector itself. Okay, so we'll actually get this to be 8, negative 6, 3, 7, negative 5, negative 1, 1, negative 4, 2. Okay, inverse 43, 35, negative 6. Okay, now from the equation star here, okay, we know that this will tell us x cubed, x squared, and x, okay, this column vector will have to be equals to 8, 4, 1. Okay, and we are obtaining this from star. Okay, so this will tell us x cubed equals to 8, x squared equals to 4, x equals to 1. Okay, which is not possible, because if x equals to 1, then x squared cannot be 4 and x cubed certainly cannot be 8. Okay, which is not possible. So, which is not possible, we write it here. Okay, so therefore, you write your conclusion accordingly. There is no for x, okay, that will actually solve all three equations simultaneously.